In this case, we have a particle at point 0 at t equal to 0, and then it moved to point 1 at t equal to 1. So we want to know what is the displacement. We can use the rectangular coordinate to locate the position point 0 and point 1. By using the right hand rule, we let the x to be the axial direction. Let the y to be horizontal direction. And then lastly, when you cross product between x and y, so x cross y gives you z direction, which is the vertical direction. Then by using the right hand rule, point your finger in the axial direction, so this is your x-axis. Point the finger to the horizontal direction and you get y-axis, and then for the vertical axis you have z. Be careful, if you switch this to y and this axis to be x, then this drawing is wrong because it does not follow the right hand rule. So to follow the right hand rule, you must ensure the x, y, z in the correct position. In the rectangular coordinate, we let the I to be the unit vector in x-axis. So you see in the x-axis here, your vector I is located here where the magnitude is equal to 1. We can write the vector I to be 1, 0, 0, which is equal to 1i plus 0j plus 0k. You should know the j and k are the unit vectors in the y and z axis respectively. So 1, 0, 0 here means that it moves 1 in the x direction, 0 unit doesn't move in the y direction, 0 unit means doesn't move in the z direction. In the vector, if you write the symbol with head, then it means it's a unit vector. So unit vector has the characteristic where the magnitude for the vector is equal to 1. It can be found by this formula. Take the square root of the 1 square plus 0 square plus 0 square, then you get the answer equal to 1. So this is the magnitude. So for your j vector, we can write it to be 0, 1, 0, and it has magnitude 1 at y-axis. So this is your j vector. And then for your k vector, it will be 0, 0, 1. So for k vector, it has magnitude 1 at the z-axis, which is this one. In simple, in the rectangular coordinate, we use this equation, and we can simplify this to be x, y, z. So x, y, z is the magnitude in the x, y, z axis. I, j, k are the unit vectors that indicate the direction. Let's say the point 0 is located at 5, 3, 1 and point 1 is located at 1, negative 2, 6. For the point 0, it has magnitude 5 at x direction. So let's say here is 5. And then it has magnitude 3 in the y direction here. It means that the vector moved 5 units in the x-axis and moved 3 units in the y-axis. Then you have magnitude equal to 1 in the z-axis. So let's say here is 1. You need to continue to move the vector in z-axis as well by 1 unit. So you see you are moving from the origin O to point A here, and then you move to the point B and point C. So you see the vector 5, 3, 1 is equal to the vector moving from O to A to B, and then B to C. From the figure, you can see that when you move from point O, A, B to C, is the same when you move from point O to C. Therefore, the summation of this vector is equal to OC. This is known as head-to-tail method, where you want to take the summation for several vectors. Head-to-tail method say that if the inner position is the same, we can cancel it. So B is the same with this, we can cancel it. So the total summation of this, we just take from head to the tail. So the result will be OC. So this is how we draw the vector 5, 3, 1 in a 3D graph. Let's try with another example here. So you have vector 1, negative 2, 6. So it's moving 1 to the x direction, move negative 2 to the y direction. So going up is positive, going down is negative 2, and then move 6 in the z direction, which is here. So 6 units to the z direction. So this is the position vector for point 1. Therefore, in this graph, the point 1 is located from the origin to this point. So this is our point 1. The green vectors here indicate the distance traveled by point 1. And the purple vector is the displacement traveled by the point 1. In vector analysis, we only interest on the displacement and we do not consider the displacement in the analysis. This is the vector that we can draw for the point 1 here. So you success to obtain the position vector for the point 1 and point 0. x0 with arrow is the position vector for point 0. x1 with arrow is the position vector for point 1. What is the vector when you move from point 0 to point 1? So this is the displacement. From this graph, x0 plus the displacement delta x, then you get the answer equal to x1. So this is the summation of the vector. Rearrange the equation, then you find the displacement to be this answer. So by substitute the position vector for point 1 and position vector for point 0, you can find the displacement. So 5 minus 1, you obtain 4. 3 minus 2, you obtain 5. 1 minus 6, you obtain negative 5. So this is the displacement vector. You can also find the magnitude for displacement by taking the absolute delta x, then you obtain square root of the 4 square plus 5 square plus negative 5 square. So after you calculate, you should obtain this answer. You should know that the average velocity can be found by using the displacement divided by delta t. Average acceleration can be found by velocity divided by delta t. If you want to measure the instantaneous velocity, then you take the limit where the delta t is approximate to 0. With that, you obtain v equal to ds over dt. Same for the instantaneous acceleration, where you take the delta t approximate 0 to obtain the a equal to dv over dt. And v here, you can substitute ds over dt to obtain the second derivative of displacement with respect to time here. For average velocity or the average acceleration, the delta t is large here. For example, you are moving from point 0 to point 1 at t equal to 0, and when you reach there, it's t equal to 1. Previously, you compute the displacement to be 8.124, so you divide 8.124 by the 1, you obtain the average velocity. The velocity might change when the particle moves from point 0 to point 1. For example, the velocity at t equal to 0.1 is different with t equal to 0.5. If you want to find the velocity at the particular moment at t equal to 0.1 or t equal to 0.5 here, then you have to use the instantaneous velocity formula.